Hey guys, today I'm going to show you how to get velocity and pressure coefficient distribution on the surface of the cylinder for 60 hertz um, as an inviscid flow simulation. So first of all, you'll right click mesh, go to press edit, and this should bring you to this part right here. And then the only thing you have to do is, in this case, I used the wind tunnel that I created for project 2. And then for my case, I'm doing part 2, so I'm doing a circle cylinder in the test section. So basically, basically, you just draw a circle at the midpoint of the test section and make sure your diameter is the right dimension, which is when I measure in the lab, which is 10 millimeters, and you should convert it into inches, where I did over here, and then also name your walls and wind tunnel. This part should be your velocity inlet. This part should be your, as you can see, velocity inlet is this wall. Your pressure outlet should be this wall. And then you should create walls from here, 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 and here. And then lastly, you need to create a wall for a circle, which is your circular cylinder, so you can measure the right value when it comes to velocity coefficient distribution and pressure coefficient distribution. After that, you go to your mesh. It's here. This is actually your mesh, and then you should go to here to design your wind tunnel and whatever and circular cylinder right here. And then when you convert 10 millimeters into inches, you should get 0.3937 inch as your diameter. And then after all, you come here to set up. And you click edit, where it'll bring you to Fluent right here. So for the video, we're doing InvestiCase at wait, InvestiCase at a motor frequency of 60 hertz. So first of all, when you come to this page, make sure your energy is on. Energy equation is ticked on, and then you press OK. The second step is to make sure your model is in InviscID, which is here. Click InviscID and press OK. And later on, you will go to your boundary conditions, click the plus, click the inlet, and then make sure your velocity inlet is the right velocity. In our case, it's 15 meters per second. When you plug in 60 hertz into your velocity of text section equation, and you get around 15 meters per second. You click apply. So, yeah, velocity magnitude should be 15 right here when you're doing 60 hertz. Click apply, close it. And now we go to initialization, and we quickly initialize it real quick. It'll tell you initialization is done. After initialization, we go to run calculation. And then make sure number of iterations is around 150, 160. And double check it and click calculate. Now you just sit and wait after the calculation is done. When the calculation is done, it will tell you the calculation is complete, and now you just press OK. And now we're trying to get a velocity coefficient distribution and pressure distribution coefficient. You go down to results, your XY plot, and since I already created this, I'm not gonna recreate it again. So I'm gonna show you how to do it. So you just right click right here, add whatever files that you created, and press edit. and then name your XY plot name. And first of all, we'll do velocity coefficient distribution. Basically, it's just your velocity magnitude. And make sure this y-axis function is velocity, and this drop-down menu, just pick velocity magnitude. And then for these surfaces, you should just press circle wall since we are only measuring the velocity and pressure coefficient distribution on the surface of the circular cylinder. Make sure to click circle walls, save plot. And now it will show you this is your velocity coefficient distribution. And then now we're doing the pressure coefficient distribution. Now you just go to pressure. Make sure you select pressure coefficient, not static pressure. And make sure to still circle the wall and say plot. And this should be your pressure coefficient distribution on the surface of a circular cylinder. Yeah, thank you for listening.